Welcome, ladies and gentlemen, to your MN36 notes. We're going to talk about the properties of rhombuses, rectangles, and squares, which is section 8.4 in your textbook, which is on page 533. The first thing I want to say is in the last guide, we talked about parallelograms. Each one of the shapes that we're talking about today is in the parallelogram family. So each one of these shapes has very specific properties, but they all have the same properties as parallelograms because they are under that family tree or in that family tree. Let's first talk about the rhombus. It's a quadrilateral is a rhombus if and only if it has four congruent sides. And that's, of course, different than a parallelogram, which is that you have opposite sides that are equal. So a rhombus is a specialty parallelogram, if you want to think of it that way. So here we have that ABCD is a rhombus, and if and only if AB is congruent to BC, which is congruent to CD, which is congruent to AD. So notice the symbols there. So I always think of a rhombus as a square, all equal sides, but slanty, like someone sat on it and caused the 90-degree angles to go slanty. The rectangle is a quadrilateral if and only if it has four right angles. So again, it's similar to the parallelogram, and all the properties of a parallelogram work for the rectangle, but the specialty thing about the rectangle is, of course, that it has four 90-degree sides. The square is actually kind of one of like, if you think of this as a family tree, is kind of like that perfect child. It has all equal sides like a rhombus and all 90 degrees like a rectangle, and that is what makes it special, that it has both all the time. So a quadrilateral is a square if and only if it is a rhombus and a rectangle. And notice down here it says ABCD is a square if and only if all four sides equal, that AB is congruent to BC, which is congruent to CD, which is congruent to AD. And notice the notation over here. And also that angle A, B, C, and D are all right angles, which also equal each other. So those are the three shapes that we're focusing on. And again, they are all in the parallelogram family. Example 1, it says, for any rhombus RSTV, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So what we're trying to do is prove this right here, or decide whether or not this is always true, sometimes true, or just plain out false. It's that angle S is congruent to angle V. Notice there is no diagram, and that's a pretty big deal. You need to draw your diagram. It's a rhombus, so I'm going to just draw something that looks like a rhombus. My drawings are horrible always. And then because the parallelogram is called RSTV, start at one of your vertices, and it doesn't matter which, and label them RSTV. Then you can look at the statement over here and see whether or not you can make a conclusion. So it's asking whether angle S, which is right here, is always, sometimes, or never going to be congruent to angle V. Well, you know what? Those are opposite angles, and opposite angles in a parallelogram those are going to be congruent, and since a rhombus is a parallelogram, that means that this is always true. So down here in the solution, letter A, right here it says, by definition, a rhombus is a parallelogram with four congruent sides. By theorem 8.4, which you don't need to know the specific name for a theorem, but its opposite angles of a parallelogram are congruent. And this is kind of getting back into that note guide from last section. So angle S is congruent to angle V. The statement is always true. Otherwise, it's not a parallelogram. If it's not a parallelogram, then it wouldn't be a rhombus. Okay, so we're looking at the same thing, same idea where it says angle T is congruent to angle V. So now, you know, when we look over here at our parallelogram, or our rhombus drawing, they're saying angle V is congruent to angle T. Well, you know what? in a typical, just everyday rhombus, the answer is no, it's not. But it could be, and here's where we get into that golden child. The square is technically a rhombus. I'm going to draw that down here, a square. And a square means you have all equal sides. That's why it's a rhombus. But we also have 4 equal angles, which is 90 degrees. And again, if we write it out, R, S, T, V, we can see that R and V would be congruent, or excuse me, T and V would be congruent. So let's just fill in what we need to fill in here. It says if if rhombus RSTV is a square, then all 4 angles are congruent, right angles. So angle T and angle V, if angle T and is congruent to angle V if RSTV is a square. Because not all rhombuses are also squares, because of course we can have one that looks more like that section A problem. The statement is sometimes true. And sometimes the rhombus looks like a square, but sometimes it doesn't. Okay, so that's kind of getting into the properties of, or the definitions of each of those shapes. Now going to the next page or the back side, example 2 here says, classify the special quadrilateral as a rhombus, rectangle, or square. So you have to decide which of these 3 it is. So when you hear this word classify, it means tell what the name of the shape is. Explain your reasoning. Well, the quadrilateral clearly has 4 congruent sides, as denoted in the picture. One of the angles is not a right triangle. Well, actually, let's kind of go back up here. The quadrilateral has 4 congruent sides. Well, a rhombus has 4 congruent sides, a square has 4 congruent sides, but a rectangle does not necessarily have 4 congruent sides. One of the angles is not a right angle. So now we're going to get rid of the square, because a square has to have all angles 90 degrees. The quadrilateral is a rhombus. That's the definition. So this is just my logic here. So this kind of allows me to decide which of those 3 makes the most sense. Now, this diagonal chart, I've got to tell you, folks, is the most important thing on this note. I mean, it's all important, but this one is the most non-intuitive, I guess, is stuff that people forget. So I'm just trying to say this is something you're going to reference. It says diagonals of a rhombus are perpendicular. Okay, so it's a statement. It's saying if you have a diagonal from A to C, and if you have a diagonal from D to B, those meet at a 90-degree angle. Okay, now keep in mind also these are parallelograms, which means that they are still intersecting at that midpoint. So, and also remember that a square is a rhombus. So a square has the same property with diagonals. So you could also, just for the sake of saying it, is that the diagonals are perpendicular bisectors. So they're not only hitting at the midpoint, but and breaking it up into 2 equal pieces, but they're also hitting at a 90-degree angle. It says diagonals down here now, diagonals of a rhombus bisect the opposite angles. And again, so we have the same idea where this side equals this side equals this side. We have a 90 degrees there, but notice this. This is, I'm going to switch into red. This diagonal, when you bring it down, bisects the outside angle. So this angle here is going to equal this angle here. And right there. And then this angle here is going to equal that one right over there. And so that plays a huge role when you're starting to try to find angle measures. And again, just a reminder, a square is a rhombus as well. Again, and I keep saying that because sometimes we overlook that square, and the square has all these properties. A rectangle, notice, clearly does not hit. Like this diagonal does not is not a perpendicular bisector of that diagonal. They do still hit at the midpoint, so this is still the midpoint, but there is no 90 degrees in there with the diagonals. But as you notice, this length equals this length, which equals this length, which equals this length. And that is a pretty big deal. It helps us out a ton when we're trying to find lengths. And again, a square is a rectangle, golden child, right? So all these um, things with the diagonals, all these properties, holds true for that square. One last thing, and notice you can definitely read this or see this on page 534 in your textbook, but I can't stress enough the relationship between all the figures. So I'm going to put parallelogram out here. And by definition of parallelogram, its opposite sides are parallel. That's really the definition of a parallelogram. Now, all the shapes that we just talked about have that opposite sides are parallel situation too, so that's why they are in the parallelogram family. But we have a rhombus, let's say over here, and a rectangle over here. By definition of a rhombus, you have four congruent sides. We don't really care about the angles, it's just we have four congruent sides. And I always think a picture helps. With a rectangle, we have four congruent angles. So here we don't care about so much the side lengths as angles. So this is all about angles, this is about rhombus is about sides. Now again, I always find a picture helpful. And lastly, a square, which again is a parallelogram and rectangle and rhombus. A square is the golden child. It has all the properties. It's going to have this, they all equal, and they have the 90 degrees. So these are some important properties of the rhombus, square, and rectangle. Thanks for tuning in.